All right, so we are going to look at being able to simplify expressions using our exponent properties. And I've reordered the problems on the paper a little bit, so the very first problem on your paper will be the last problem we do. So just wanted to make sure, you'll notice that the first three problems on your paper are very similar, and it's what we are trying to focus on is what is the base and what is being raised to the negative exponent. And so if we look at that, I'm going to take and say that I know that the 3 is the base here and it's being raised to the negative 2 power. And so I'm going to have to make that move from the numerator, where it's currently located, to the denominator. Notice that the base stays exactly the same. It's a 3. It's the exponent that changes from a negative to a positive. And then I apply that exponent rule of 3 squared to get 1/9. Now, if you compare this original problem here, 3 raised to the negative 2 power, to our next problem, notice that what we actually have here is a coefficient of 3, and then just the x is being raised to the negative 2 power. So really, there's like an implied set of parentheses that are in there. So what that means for us is this all starts in the numerator, but the 3 is going to stay in the numerator. The 3 is not raised to a negative exponent and therefore does not need to move. But the x as a base is raised to a negative exponent and it does need to move to the denominator. And so that's our simplified there. If we look at this one just a little bit different, look how those parentheses are around the 3 and the x. That means that both of these things in here are the base. What it really means is that the 3 is being raised to the negative 2, and that the x to the first power is being raised to the negative 2. And since those are both in the numerator, to make those exponents become positive, they will need to move to the denominator. Notice that the base 3 stays the same, but that exponent of negative 2 switches to positive 2, and that the x to the first power stays the same. It's the base, or the exponent of negative 2, that switches to positive 2. Now, if this went to the denominator and this went to the denominator, that means the only thing left in the numerator is a 1. And then I've got to finish doing these properties. 3 to the second power is 9, and then x to the first to the second power is x squared. And then this last problem, which is actually the first one on your paper, says which one does not belong. So if we look at this here, we have 0.5, which we should recognize that this here and this here, we just have the decimal and the fraction equivalent. And then what we see here with this particular one is this 2 to the negative 1. And that's actually in the numerator. And so if we take that 2 as a base and move it to the denominator and make it to the positive 1, and the only thing that would be left is a 1 in the numerator, we could see that 2 to the negative 1 is just the same as writing a half. So we now have the fraction form 1/2, we had the decimal form 1/2, and then we had this negative exponent form that was 2 to the negative 1, which is actually, as we can see when we simplify it, 1/2. And so therefore the thing that does not belong is this negative 2. All the other ones have the same value. Negative 2 is a completely different value.